Hello friends, this presentation is of trigonometry presented for quality improvement in maths education project under the guidance of Professor Inder K. Rana of IIT Bombay and Professor Santosh G. Gharpure of IIT Bombay. This video is presented by Mrs. Pallavi Mahadeshwar, registration number MTE020. I am from Queen Mary School of South Mumbai. My subtopic is applications of trigonometry. Let's observe this clip.
At some point in our life, we all had to study trigonometry. However, the practice of using trigonometry is not only limited to our textbooks. For example, take a look at this. One side of this right triangle is missing, but you can still find out with trigonometry. Assume the longest leg is 100 kilometers long, and the shortest one 50.
As you can observe,
and of course, the
right
last
angle
one
triangle
we do
and
not
Pythagoras
know.
theorem is
Well, the solution
applied.
to this problem is relatively easy. All you have to do is use the a squared plus b squared equals to c squared equation. In this case, which c will be the longest length, and a will be the shortest length, and b will be the unknown length. All you have to do to solve this equation is enter 100 squared equals to 50 squared plus b squared. And then you should solve for b and you have the answer. And that means that if you want to swim across this area, you have to swim 7,500 kilometers.
Well, those are some examples of trigonometry in real life. But wait, there's more. Trigonometry is also used in our GPS technology. Triangulation is a process that works by using the distance from two known points and is used in cell phones equipped with GPS technology. A GPS receiver measures distance using the travel time of radio signals from the satellites.
Are you stupid?
If someone is between two cell phone towers on a highway, the position north and east of the first tower, and the distance from the highway can be determined using sine and cosine.
Recalculating route. You're not good at following directions, are you? Pay attention.
Trigonometry is especially important in architecture because it allows the architect to calculate distances and forces related to diagonal elements. For example, on bridges and tall structures, the diagonal has to be strong and accurate to keep the structure standing. Trigonometry also applies to sports like table tennis. Understanding how sine and cosine functions work in terms of physics can be really beneficial to sports players. Did you see that? That's exactly what I mean.
Yes, so trigonometry is also beneficial in sports. Now, why trigonometry? Why right angle triangle? And why the triangle is so important? Imagine we can measure along and up, but we want to know the direct distance and angle as well. Trigonometry can find that missing angle and distance. Or maybe we have the distance, we have the angle, and need to plot the dot along and up. Then, such questions are very common in engineering, computer animation, and more aspects. And the trigonometry gives answers to all. Let's see applications of trigonometry in the real world. Air-to-air refueling. Air-to-air refueling is to save time or because of lack of landing facility for large jets. In some parts of the world, the military and civil companies use air-to-air refueling for some planes. Boat safety. Now, to find the distance from the boat to the base of the cliff for safety of passengers as well as the cargo is very essential. Few more applications of trigonometry are as follows. Flight safety, that is particularly in the foggy condition, the height of a cloud or a fog cover over an airport can be measured. Space flight, particularly while landing, to know the gliding angle Trigonometry must be used for shuttle to touch down at the beginning of the landing strip for safety measures. Few more applications are as follows. Lightning protection, particularly in the midst of the seas. To estimate the height of the lightning rod on sailboat to produce a cone of safety on the water. For calculating the length of the pipelines on the terrains which are difficult to access. Also in the architecture, to control the sun exposure of house to be built. Surveying the height of mountain can be found using trigonometry. Where else can we use trigonometry? If you know the height of the building and angle of elevation, you will know how far you are from the building, or you can locate an object, you will find the distance of the object in deep waters to find the angle of elevation, or to find the distance of the object which is flying in the sky like a kite, or to measure the height of the monuments. Now for this purpose we can also measure distances very easily using our protractor. Use a protractor to make a clinometer to measure angle of elevation, and thus we can easily find the distances and the heights. Let's watch few more applications. Now how do we do this? Simple, using trigonometric ratios. Now to understand the trigonometric ratios, what we need to understand, the basic triangle, yes, our own right angle triangle, which has hypotenuse exactly opposite to the right angle and also has two acute angles. We name one of the acute angle theta. We locate the side opposite to it and adjacent to it. So the three sides are very helpful to find the trigonometric ratios as follows. Sine ratio is side opposite to theta divided by hypotenuse. Cos ratio is side adjacent to theta divided by hypotenuse. Tan ratio is defined as side opposite divided by side adjacent. Chord ratio is inverse to tan ratio, that is side adjacent divided by side opposite. Then a secant ratio, which is hypotenuse divided by adjacent side, which is inverse of cos ratio. Then sine ratio, inverse is cosecant ratio, that is hypotenuse divided by side opposite to theta. From this we derive a table which gives us a standard angles, that is sine 0 has a value 0, sine 30 is half, sine 45 is 1 upon root 2, sine 60 takes value root 3 upon 2, sine 90 is 1, cos 0 is 1, cos 30 is root 3 upon 2, cos 45 is 1 upon root 2, cos 60 is half, cos 90 is 0, tan 0 is 0, tan 30 is 1 upon root 3, tan 45 is 1, tan 60 is root 3, whereas tan 90 is not defined. Now these angles can be memorized by easy methods which are available otherwise. Also, we can easily find them in the logarithmic tables. Let's watch. Now, if we are given the angle of elevation and we know the height of the pole, in that case we know how far the boy is from the pole post. So tan 30 is 2.4 upon x, and thus you get the value. Same way, if you are given the distances, you can find the angle of elevation, that is tan theta is equal to 2.4 upon 25, then you get theta accordingly 5.5 degrees. Let's solve few problems. If aircraft is flying 2500 meters above the ground and a man observes it at elevation of 30 degree, calculate how far is the man from the aircraft. Now we are given theta is 30 degree, whereas opposite side is 2500 meter. Hypotenuse is unknown to us, so we use sine ratio, which is side opposite divided by hypotenuse, for sine 30. That is equal to 2500 divided by hypotenuse. Sine 30 is given a value half, that is equal to 2500 divided by hypotenuse, that is unknown side. Thus hypotenuse is equivalent to 2500 into 2 is equal to 5000 meter. Thus answer is the man is 5000 meter away from the aircraft. Isn't that simple, guys? Now let's go for the next problem. A hot air balloon was observed at 60 degree elevation. After some time it was observed that it is 30 degree elevation from the same place. If the balloon is at the same height, 88.2 meter above the ground, how far did the balloon travel in that span of time? Now, at first position, the balloon is with the angle of 60 degree. So we find tan ratio, side opposite to theta divided by sine adjacent to theta. That is 88.2 divided by AB is equal to tan 60. That is AB is equivalent to 88.2 divided by root 3. Now at the second position of the balloon, it is making an angle of 30 degree with the ground. So tan theta again is side opposite divided by side adjacent is equal to 88.2 divided by AC, and that is equal to tan 30 now. In that case, AC is equal to 88.2 divided by 1 upon root 3. Now we have value of BC equivalent to AC minus BC. As you can see, ABC are collinear, so BC is equal to AC minus AB. In that case, you get 88.2 into root 3 minus 88.2 divided by root 3 equal to 88.2 into bracket root 3 minus 1 upon root 3. Now we use the rationalization method and solve it further. So BC is equal to 88.2 inside the bracket 3 minus 1 upon root 3 is equal to 88.2 into 2 into root 3 upon 3. That is, finally when you calculate, you get 101.72 meter. So balloon has travelled 101.72 meters. One more problem. The top of a tree has broken by wind, falls to the ground at an angle of 30 degree at a distance of 8 meter from the foot of the tree. Find the original height of the tree. Now, let's consider AC is the original height of the tree. Let it be broken in parts which makes an angle 30 degree with the ground. It is broken at point B and AB is equivalent to BA dash. Thus, in triangle A dash BC, we have tan 30 equal to BC divided by A dash C. So that is BC divided by 8 is equal to 1 upon root 3. That is a value of 30, tan 30. So BC is 8 upon root 3. Then in the same triangle, we find the cosine cos ratio, that is cos 30 is equal to A dash C divided by A dash B. So we substitute the values at 8 divided by A dash B is equal to cos 30 root 3 by 2 and we get A dash B is equal to 16 divided by root 3. Now since AB is equivalent to A dash B, we add the distances, that is AB and BC, to get the height of the tree. So A dash B plus BC is same as AB plus BC. 16 root upon root 3 plus 8 upon root 3 is equal to 24 upon root 3. That is equal to 8 root 3 meters. The height of the tree was 8 root 3 meters. Now we can even multiply root 3 or substitute root 3 by 1.73 and multiply it by 8 to get perfect answer in decimals. We have one more problem. Let's solve this. If we know that the distance from the earth to the sun is approximately 930 lakhs, that is 9 crores 30 lakhs miles, and we find that the largest angle between the earth and the sun line and the earth and the Venus line is 45 degree. How far is Venus from sun? Now we have a small diagram for disposal. You can see here this is earth, then Venus, sun. So we have taken it into consideration the right angle triangle making 46 degrees here. So we need to find x, that is the distance between the sun and Venus. Let's see how. We have sine 45 is equal to x upon the distance between, that is 9 crore 30 lakhs miles, that is sine 45 takes value 1 upon root 2. So x is equal to 9 crores 30 lakhs point sine 45, that is converted to 1 upon root 2. Finally by calculation you get this answer as 6 crore 57 lakhs 60,931 miles. That is too huge, but we can solve these problems as well. One more problem. A boat is cruising along the coast on a straight course. A rocky point is sighted at the angle of 31 degree from the course. After continuing 4.8 miles, another sighting is taken and the point is found to be 55 degree from the course. How close will be the boat from that point? Now let's see. We have the solution. Referring to the diagram, y is the shortest distance that the boat will be at a point, that is from the rocky point. Y is the shortest distance. Now to find y from the small right angle triangle, that is of the 55 degree, you can see here the distance between the boat and that perpendicular point is x. Cot 55 is x upon y, that is equivalent to x is equal to y cot 45 or 55. Now the large angle 31 degree. Cot 31 is 4.8 plus x, that is the distance 4.8 plus x, divided by y, that is the opposite side to the angle as per the cot ratio, implies y cot 31 is x plus 4.8. We have two equations and we can compare the equations. In that case, from equation 1 and 2 we get y cot 31 is equal to 4.8 plus y cot 55. Now we solve mathematically. We get y is equal to 5.0 miles. Thus, calculations can give you simple answers for the so-called tedious questions through trigonometry. We have few more problems for practice. A person is standing 20 feet away from the lamp post. If the lamp is 18 feet above the ground and the person is 5 feet 6 inches tall, how long is a person's shadow? This too you can find easily with trigonometric ratios. One more problem for your disposal. A 5-foot fence is 4 feet away from the building. Now a ladder is to go from the ground across the top of the fence to the building. Find the length of the shortest ladder that can accomplish this task. We have one more problem. Please cast a shadow of 32 feet. At the same time, a vertical yardstick 3.0 feet cast a shadow. The vertical stick you can see here 2.2 feet. How tall is the tree? Again, by comparison, by similarity or by trigonometry, you can solve this question. Now use this information to find from the figure, of course, the length of the island. Here it is given. And last question, to tracking. Thank you for your patience.